Yeah, definitely. It takes it for sure. So the solution should take about half an hour or so, and then we'll talk about the next project. Um, make it, or if you just want to take a break and back, or who's doing the basics? Yeah, I'm sorry. What does the same mean? Okay, yeah. Do they take like square payments or credit payments? I never carry cash anymore. Okay. All right. Sorry for getting a late start here. Hope you folks are doing well. We're just talking about a bake sale happening over at the UC, so hopefully we'll should have some time to go hit the bake sale here. So let me fire up PyCharm. We're going to take a look at Project Zero. I want to show you how I would solve it. And again, if you solved it differently, that's okay. There's lots of different ways about how we can write our code. It should all do the same thing, but what it looks like is a little bit different here. So I like going over those. So this will be Project Zero. And I got to pull up that canvas here. Probably don't need my WhatsApp open anymore, right? This one of my coworkers' sons played the cello for like a statewide competition. He got second place, and I used to play the cello, and I was listening to it, and it was amazing. I was never that good, so. All right, let me pull up our project here. So we're going to build out the classes, we're going to build out the tests, and we'll do the UML diagrams. So again, there was no functional code here. We weren't actually building any part that runs aside from the unit tests. So the goal was write the classes, make sure they do what they're supposed to do, and then go from there. So for our ship base class here, this is the first one we'll start with here. So I'm not actually going to put anything in main PY. Again, if you put all your classes in main, great, that's fine. Different organizations have different standards around what goes where or how you want to split out your classes. I like one file per class because that's what I like. And really, that's the only reason. So I'm just going to add a new file for ship here. And ship is the base class, so there's nothing we need to import here. This is the main one here. So this is just class ship. And then we'll define our init method, init here. And init needs a bunch of things, right? The idea with init, you need to give it a name, an X, a Y, an alignment, a max health, a range, and attack power. And I said the types here, like these are the values we expect to get. Technically, you can do this in Python 3. We never really got into that, and I skip over it all the time because I haven't seen it be that common. And Python usually is typeless, where you say you can give me a name, and if you give me a number for name, I'm going to take it anyway. It might screw up my code, but we're just going to accept it. So there's things you can do in Python that are a little bit more specific around you must give me certain types, but it hasn't really caught on yet because it isn't really what Python does. So this was more the UML style, like here's the attribute, colon, here's the type, just to give you some information about it here without giving you everything. So I'm going to have name, I'm going to have X, Y, alignment, max health, and range and attack power, right? Range and attack power. Sure. So we'll take a bunch of values here. Let me see if I can, might be zoomed in a little too much. Kind of want that to fit on one line. Now it's warning me range. There's something else called range, because like we would range through the list of something. It can get a little funny if you're doing that here, but we're not going to use the range function, so it's probably okay. And then this is our ship class here, right? And part of our points, right, was writing out the class, right, writing out the test, writing out the UML diagrams. So I didn't specifically ask for you to make these things private. It's good practice to make our values private. So if you made them private, good. If you made them public, you're not losing points, but probably should be private, right? And if we want to be changing these values, we need to give them public functions to do that. Again, not too particular on this assignment, but that's the kind of thing we want to think about. Like, do I just want someone to tell me what the X location is, or do I want this only to change through the public move method, move function? Right? It kind of depends on what's happening in our game here. So, once I put a ship somewhere, it probably doesn't change aside from move. So I would think these would make sense to be private. Alignment would make sense to be private because we have that public change alignment function to change alignment here. Range doesn't ever seem to change, right? We don't want to let someone say, hey, ship, your range is now 500. Again, these weren't clearly defined, and that's okay. And that's part of when we're writing software. We don't always get everything. We get here's this, and then we have an idea of what it's supposed to do here, but it's not always completely defined for us. Now, generally, when you start out as more of like an entry-level junior developer, you've got people who are experienced doing the design process, and they'll give you more details because they've done it before and they know, oh, by the way, when you're writing it, you're going to need these details. They'll fill in the blanks here, or you can go ask people about it. But when the business comes and says, hey, I want to make a game where you can move ships around the board and they shoot at each other, sometimes business folks are dumb. And not dumb, I'm sorry, not dumb, that's the wrong word, but like they don't know that this sort of stuff matters. So like when we're writing the software, well, can it move? Can I change its X and Y outside of this move method? And they're like, oh, I don't know, I haven't thought of that. Sure, or no. Like, so it takes some of these questions. That's part of the design process of when we're doing it. So this, intentionally vague here. And hopefully that was okay, that it didn't say, yes, do it this way, or no, do it this way, or you have to do it this way. So those are, questions we should be asking ourselves as we go. So for name, I don't think name matters if you want to go change the name. This idea, like, if we don't want people changing things, or if we want to put constraints around what is valid, we definitely want to make them private. Right? So self, I'm going to say X location and Y location. Location equals X, and self Y location Y. I want these to be private because the way I'm going to write it, and again, if you did it differently, that's okay. That's not wrong at all. Is that it only ever changes through the public move method, move function. Okay, self alignment, the alignment, self, and then max health. Again, I think probably should never change. Just it's what it is. Current health definitely shouldn't change directly, right? Because we have the assess damage method function. I'm sorry, I keep going back and forth on those. That sets those things, and current health just starts at max. When you make a new ship, you're at full health. You're not damaged or anything. Again, range I'll make private, range, and self.attack power, attack power. So name I'm leaving public because I don't really care what people do with name. You want to call Bodie Boatface, go for it. You can have fun. You want to be the USS Enterprise because you like Star Trek, go for it. Sure, that's all fine here. Why is it? Oh, no lines. So here's my init method, right? It sets all my values. The init's job is to give values to all of my instance attributes here. The other piece we're missing here is the alignment. So I'm going to make a separate file for alignment. I guess we do need an import here, don't we? So let's do alignment. And then my class alignment can inherit from enum. So was it from enum, or is it just from enum import enum? Alignment. I can't spell here. There we go. Right, and then we are just going to have our values here. So we're going to have, us equals 1, them equals 2 or something, and chaotic equals 3. Just so we have some nice names for alignment. So I don't have to say, hey, there's our string value and compare string values. And this sort of thing does give you efficiencies as we look at, performance and cost of things. Storing a numeric value is much faster and easier and smaller than storing a string value. And comparing numeric values is much easier than comparing string values, right? So in terms of how much it's going to take, this is a good 2 blank lines, sure. Okay, so there's our enum alignment here. So we can go import from alignment, import alignment. Right, that's this way we have it here in ship, so we can go and use that alignment later. Yeah, so there's ship, there's our init. We're going to attack another ship. Okay, sure. So we'll define an attack function here that takes a target, another ship. It should be some ship here, right? And whether or not it's the base ship class or one of the subclasses, great, we're going to attack. So for ships, we don't attack our own team for us and them, and chaotic attacks everybody. So if we're going to attack them, they need to not be our team or we're chaotic, and they're within range, right? So we can check to see, hey, so if self.alignment is equal to alignment.chaotic, then great, we're going to shoot. Doesn't matter, right? Or if the self-alignment does not equal the targets. Now, I can go get their alignment directly, but we shouldn't do that. It's better to use the public functions here. So we probably need some sort of public function or get alignment here for a ship. So we can return self-alignment. Right? We want people to use public functions. We're going to use these public functions. So this will be or my target.get alignment. slash, nope, other slash. Okay. So this is, should I be shooting at them? Right? And then we can check for range. And I could add that in here and do some order of operations, or we can have an inner if. It's probably better to have an and. So we'll say if this is true or this is true, right? And they're within range. Now, just thinking ahead here, because I know we're going to use this, I need to check if we're within range for a couple different places. So if I just put all the code right here, I'm either going to have to copy paste it or change it later. So I'm just going to save myself a little bit of time and add a helper method here and say is target within range. Target within range given a target, because I want to be able to use this public function, this function here later, because cruiser, my repair ship cares, my corvette cares if they're within range, because they do something different than my attack. So if you put it all in here first and then come back later, that's great. I just want to skip that second, and we'll just jump right to adding this function here. So we're just going to return my self.x location minus the target dot, and again, we need a way to get their x and y. So let's go add some get methods. Define get x, or just get x. Sure. Return self.x location, define get y. And these are things, if you didn't add them in, that's okay. Right? If you said, hey, you know, the spreadsheet or the document says these are the methods I have, I can't add more, it's okay. I'm not going to fault you for it. Usually this is like the minimum we must have. And if you want to add to it, that's great. So again, intentionally vague. This is, you know, as we're working through writing our code, oh, you know, it'd be nice if I had this. Yeah, that's a great idea. Let's do it. Design can change as we're coding. That's fantastic. It's good to go and change things and improve things and make your life easy here. So return self.y. All right. So then my x location minus the target's get x location, get x. Right. And we'll take that squared. Right. Plus, and oh my goodness, the self.y location minus the target dot get y squared. Right. So those two added together, all of that square root, math dot square root of that. We're going to import math. Yeah, I guess we have to import math. Math, sure. So take the square root of that. That should be the hypotenuse, right? If that is less than or equal to my range, right? If that's true, I'm going to return true. If it's false, I'm going to return false. So I don't need to say like, if this return true, else return false. Save it here and just return, this is a true or false value already, right? So this is if they're within range. Great. So then I can check. Okay, so if I'm chaotic or they're not my team, and self.is is target within range, then I can go shoot them. Right. So to do that, we'll say target, and we need some more functions here, right? We need this assess damage function. So we'll go add the assess damage, right? For them to take damage, this is our public way of changing their health, their current health. So we can assess damage given an amount, right? And the idea with assess damage is we need to make sure it stays within bounds of 0 and max. Okay, sure. So I'm just going to take the self.current health and I'm going to subtract the amount. Then I'm going to check for bounds. If you check for bounds first, great. If you check for bounds after, great. It should be fine. Either way is okay. So if my self.current health is less than 0, I'll take my self.current health, set it to 0. Right? If it's not less than 0, elif probably makes sense here. It could just be another if, but then, you know, if it was less than 0, it won't be. So we're doing like one extra operation. So sure, this is probably better. Greater than self.max health, self.current health equals self.max health. Now, this probably seems a little funny here, but what this lets you do is give a negative number to amount. So later, like when our repair ship goes and repairs ships, it can use assess damage and give it a negative value to increase its health. If you said, oh, well, I don't really know how to repair a ship, I could add another public function for it. Great. You could add a public function for repair that just sets health to max health. That's an option too. You know, this way is probably a little easier, and you know, I think the hint here of keeping it within max was your hint to use this one. But again, lots of different ways you could have gone about that. Okay, so we have an assess damage. So then we can assess damage. Assess damage given our self.attack power. right? They take our attack power damage if we attack them. I think that should be tabbed in one, right? So why does it not like these? Okay, sure. Okay, that's attack for ship. Okay. Oh, we had get X and get Y. I'm sorry. Yeah, we did have those. Get alignments. Get type here. Let's go get type. Define a get type. So for ship, we just return ship. For battleship, we'll return battleship. For repair ship, we'll return repair ship. On and on and on. This is just gives you a nice little string version here of what our type is. Status has a very particular format. Sure. So we'll define a status function here. It's going to return a nicely formatted string here of a bunch of stuff, right? And that bunch of stuff is this. So name, right, will be self.name, and then a new line, right, because we're doing all this in here. I think, do we want this as a, can't do the raw string. I can do a formatted raw string. This might be easiest here. I want to format this. Then I think I don't need the new lines. Does that, doesn't like self though, shoot. All right, maybe we can't do that. We'll go back to this. We'll add in the new lines. That one plus formatted string of type, and this is then self.getType, right? That should be the type that we are, right? Plus a new line. These get ugly. I'm sure we could do better here. I'm feeling bad now, but it'll be close enough. This is my health, colon, self.current health. Or yeah, sure. Either one's okay. Get type, definitely need to use get type, because when we use subclasses, it will use the get type version that the subclass implements. So we'll get the correct, is it a ship, a battleship, a cruiser, that sort of thing. That works out well. So there's health, and then our location. Plus our formatted string of location, parentheses, parentheses, sure. Self dot. And get X actually is less typing here, right? Self dot get Y. Right? So there's our status. So it just returns a formatted string with all that information. Okay. Sorry, my sugar's a little high. One sec. What is going on here? All right, cool. All right, and then change alignment was next. Change alignment, changes us to them to us, and chaotic stays alone. So if self.alignment is equal to alignment.us, then self.alignment becomes alignment.them. Right, just flip it. Else if my self-alignment is equal to alignment.them, then we'll change to us. Alignment equals alignment.us. Chaotic, nothing happens. Right? They stay chaotic. We don't get to turn them to our team. They just stay like that. So we don't even need to check. Nothing happens. Okay. So there's ship. I think that's all the things that ship was supposed to have. Oh, move. We need move. That's right. So move moves the ship and increases health by 1. Okay. So we got a couple options for this here. Probably the easiest way here is we'll just say self.assess damage -1. All right, we've gained a health. We haven't moved anywhere yet. So depending on how you want to tackle this, we can add more attributes for how far we should move, or we can let our subclasses override this and do their own thing. Now, the problem is we've said these values are private. So when our subclasses go and access them, we're technically doing bad things. We're not going to feel great about that. It'll work, and it might be easier than trying to add more additional information here. We could add a X vector and a Y vector for move as attributes and pass them to the init method if we wanted. That's an option. Or we just go access the values and change them. That's also an option. Probably not the better one, but that's probably easier and probably what most people went with. So that's what I'll show. That's probably what you did. All right. So now we don't have any tests though. We don't know, does it do what it's supposed to do? I don't know. We got to figure it out. So I'm going to go write some tests. So let's go to test. Say there are no tests. Let's make some tests. Now, again, I don't test the gets usually because testing them separately is a bunch of work that really I'm going to test them when I try the init method, because I want to make sure init sets everything correctly. And when you use init, I'm going to go get all the values all at once. So I'm going to shortcut there. All of the gets will be tested when I test init. But what I do want to test then is assess damage. I want to test move, status, right? We'll kind of include the get type. We could do get type. It's probably not too bad here. Test alignment, test attack. This is target within range. This is a private method, private function here. It gets used in test attack. So I could test it separately, but because it's being run in attack, right? Attack is really the unit of code I want to test. And if it doesn't work, then I'll have to find out where the bug was. So I'm not going to test it separately outside of that. I'm going to test attack because that's the public function here, and it gets used in that. So the gets we don't need. All right. So we'll first do our test init here, because that's the first one I want to test. So we'll make a ship. So we're going to arrange, we're going to act, and we're going to assert. So to create something, we'll make a ship equals ship. And we have to give it a bunch of values. So all the values we're going to give it, we should expect to get back out. So we'll have an expected name. Name is, I don't know, some ship. Sure, why not? We'll give that to expected name. Expected X. I don't know, something other than 0 is probably good here. I don't know if it matters too much here, but we'll give it 1 and 1 for X and Y. The expected X, the expected Y. Oops, those are backwards. X and then Y. Maybe make them different too, because it's easy. It's like if I flip them around in the wrong order, the same code is still running, but it's probably a better test if we're giving it different values, just to make sure we're getting different values back out here. Then alignment. So we need to, from alignment, import alignment, and then from ship, import ship. Awesome. So let's make this alignment dot us. Why not? And then we need to give it max health, range, and attack power. So we'll add a couple more expected max health. I don't know, we'll say it's 20. Expected range is 25. And expected attack power, we'll say is 10. Right? These don't really matter too much, but as long as we give it some value, we can go check what it is after. The expected range and the expected attack power. Right? If you put numbers in here, it's not as good as having nice named variables, because we're going to test these things later and assert on them later. Might as well name them. That's a better habit here. Let's ship. And actually, this is what we're acting on. So it's probably better to go in the act section here, because this is the code we're testing. We're testing the init method here. Then we'll go get all the values back out. So then we'll have an actual name equals ship.name. Now we didn't have a get function here, but we're still going to check if we got it here. An actual X is ship.getX. An actual Y, ship.getY. An actual alignment, ship.getAlignment. An actual max health, ship. Oop, we don't have one yet. Right? We should probably have a way to get their max health back out. Right? If you didn't write one, that's okay. You probably didn't have to test it then, because you didn't have any code to test. Right? But it's probably a good thing to have here. Get max health. Heal. There we go. Ah, that's the wrong button. There's a page up and page down in the weird spot here on this keyboard. Define get current health. Turn self.current health. Okay, and then range and attack power. Get range. Turn self range. And define get attack power. Self dot attack power. No. Attack power. There we go. All right, so now we have all the gets. We can actually use the rest of these. So ship.get max health, an actual current health, ship.get current health, an actual range, ship.get range, and an actual attack power. Ship.get attack power. All right, we'll get all the values back out. Then we're going to assert. So self.assert, and then most of the time, again, we're using equals here of the expected name and the actual name. Oops. Actual name. Self.assert equal, and we'll just do a bunch of these here, right, for all of these different values. So a couple in here, and then we'll go through and take all of our expecteds. Expected X, expected Y, expected max health. And actually, I'm going to repeat this one here for the actual current health. This current should stay at max. If you want to have another variable for it, that's probably nice and proper. All right, I'm going to feel bad. So I'm expected current health 20. All right, I feel bad. We'll go use it. Expected current health, expected range, and expected attack power. Right, these are all the things we expect given what we set here. So we'll have our actual x, our actual y, and our actual max health, and our actual current health. So I'm just typing a couple letters and letting it suggest the right one for me here, and arrowing and tabbing. This is I don't like to type more than I need to. So, all right, does this make sense for our test here for testing init? Let's give it a run. See if it works for us. Uh-oh, it failed. None does not equal 20. Well, that is on my expected max health and my actual max health. So, oh, we never tested alignment. Oops, I missed one. X, Y, we should do cert equal the expected alignment. Oh, we didn't have one. Oh, that's my mistake. So we should have had an expected alignment. That's why. Expected alignment is, there we go. This is the us here. And the actual alignment. Okay. Expected alignment and the actual alignment. All right, which one failed? Our max health here. So get max health. So ship get max health. Get max health returns self max health. Okay. It should be set to max health. So something might be wrong here. This is interesting. 20 does not equal none. Yep. So return. This is kind of why these are useful, right? Because you do dumb things. I do dumb things all the time. So, and you know, I'm happy to admit that. So, all right, let's try it again. Hey, now it passes. Okay, now I feel better. It passed. All right, so assess damage. So we're going to arrange, we're going to act, we're going to assert. Now, in terms of code coverage here, my assess damage has this if block and this if block. Depending on how you wrote yours, it might be different. But I know if I want 100% of the code to run while I'm testing, I need one test that makes sure this runs, one test that makes sure this runs, right? To make sure that both of these blocks are being run here. So I'm going to have two different tests here. So this is test assess damage doesn't go below 0, right? You can just name these things just like you name your variables. Name it something nice here. And this will be doesn't go above max, right? So for testing assess damage, I just need a ship. So ship equals ship. So I need some ship. I don't care what the name is. I don't care what the X is. I don't care what the Y is. I don't care what the alignment is. We do care about health though, right? So the ship's max health matters here. So I'm going to have an expected current health equals, I don't know, we'll start it at 20, right? So its max will start at 20, right? And then the other values, I think we can just give it zeros for range and attack power, and just two more, range and attack power. Okay, so I have a ship to test. Then I'm going to go change its value. So I'm sorry, this should be 0. Oops. Nope, my expected current health should be 0. The starting health should be 20. Right? So we'll have it starting health is 20. That's right, because I wanted to not go below 0. I was doing the wrong test here. So I expect it to stop at 0 here. So when I call ship.assess damage, and I want to assess the starting health, I don't know, times 2 or something, let's say it takes double what it had. It should stop at 0 when it goes down, right? And again, any sort of way of doing this is fine. If you put hard-coded values in here, it's not bad. I just prefer using variables for anything that is a meaningful number. And this way, later, if I want to change the test, I can go change those values and sorts of things here. And then we'll get the actual health. Actual current health equals my ship.get current health. And then we'll assert to the match. Self dot assert equals my expected current health, my actual current health. Right? If I start with 20 hit points and I take 40 points of damage, I should stop at 0. It should be 0. So let's give this one a run. Nope. Expected indented block. What did I do wrong here? Oh, this one is this one just needs like pass here. the file wasn't compiling or being interpreted. There it goes. Okay, so this one passes. So basically I'm gonna do the same thing here for this one, but I'm just gonna stay at 20. So if we start at 20 and we assess negative amount here, about negative current health, should still be 20. Right, so using some variable names makes this like, so my test line here is easier. So I like doing that here. So let's see if that one runs. Cool, so that one passes. So in terms of code coverage, I think that this block is running and this block is running, and I have a pretty good feel, that's what I meant to do, and I can eyeball it, and I'm pretty sure it's doing that here. If we really wanted to look at it, we could run in the debug mode and actually watch it, but that's not very exciting right now. Okay, testing move. So move should increase our health by 1. So we probably need to decrease the health a little bit to then make sure it does go up. Because if we start at max health, nothing changes. Not a very interesting test here, just in case something else screwed up. So we're gonna arrange, we're gonna act, and we'll assert. So we need an expected health, say is, 11. Sure, we can pick any number we want here. We'll make a ship. So most of the time these ships are kind of boring here. We'll just copy from here. Now let's start at 20, right? Then what I'm testing is that the health goes up when I call move. So I'm going to assess damage here because that's how I can change the damage health of the ship. I'm going to take 10 points off. So it should start at 20, go down by 10. Now this isn't great because what we're testing here is the move unit of code, and then now we're kind of depending on assess damage to work, but we don't really have a lot of ways around that. So I'm going to use assess damage to change his hit points so that I can check to see if it goes up when I call move. So sometimes my functions depend on other functions, and that is just what it is. So then we'll call ship.move, and then we'll get the actual health, actual current health, by ship.get current health, and I think this assert is the same one then. Right? Does the expected current health. There we go, current health. Match the actual. Right? Did it go up by 1? So it should have gone down by 10 and then up by 1. And it seems to work. Right? Right, get type, range, act, and you don't have to do these comments every time here. I'm just trying to put it in just to keep myself organized here. So we're gonna have an expected type is ship. We need to make a ship, and we don't really care about ship, so we'll just make one. Sure, we just hard code the values in, and then my actual type is ship.getType, and we'll assert ship dot self assert equal expected type and the actual type. Right, see if that one passes. Ship has the most tests. The other ones are pretty quick here. Okay, that's great. Status, and this one's a little longer here, so we need ship as a ship. Now this one is going to matter here what we give it, because name should come back out. Ship name, sure. X and Y should come out. The current health should come out. Right, range and attack power don't come out of status. We don't care. If you want to use variable names here and do some substitutions, great. It's not, I don't know if it's the end of the world here or not, but then we'll have expected status should be ship name. This one I think we can put as the triple quote string, right? I think this will make life easier for us. So ship name should be the name, right? And then we had the, oh my goodness, I don't even remember what was in status now. Where'd my status go? Here it is, type. So then type colon ship, and location was going to be 1, 2, and health, was it health? Current health? Oh, health was first, oops. Health should be 20, location 1, 2. I think the string should end there, right? We didn't have any extra new lines at the end of this one, at the end of location. So I think this should match our status. So then we'll get actual status is ship.status, and then we can self-assert equal my expected status and the actual status. Let's see if that one runs. These ones are a little tricky sometimes when you're dealing with strings. Yep, we're close. So doesn't match. So we have ship name, type ship, health 20, location 1, 2 does not equal ship name, type ship, health 20. Location. Do we have? I think we have an extra new line here. Is that the problem? Might be this. Let me try that. Strings are annoying. Nope. Looks like it's the same. Do I have wrong spaces? My space is wrong. Nope. New line. X get Y. Why is this? Oh, click to see the differences. Location, my comma. Yep. So it's my comma was off here. That's awesome. So where's my comma? There. X comma space Y. Right. I had the other way around before. There it goes. Okay, now it passes. Cool. Change alignment. Now again, there's two different blocks here. Right. So this will be us to them. Them. So we'll make a ship. And then have an expected status or expected alignment dot. So if we are us, we should change to them. Ship dot change alignment, and then an actual alignment. Ship dot get alignment, and self assert equal the expected and the actual. Right? That's an us to them. We can test them to us. Now, you might want to test, but again, in terms of code coverage, it doesn't really add anything, but testing that chaotic doesn't change. It doesn't hurt to have the test there and say, hey, does chaotic stay the same? We're not getting any more code coverage out of it, but in terms of are we testing the things that should happen, it's probably a good thing because we know this is something that was supposed to be a rule here. Let me make sure it does it. So we'll say chaotic doesn't change. Chaotic doesn't change. Chaotic. Chaotic. And if we start as chaotic, we should stay chaotic. We'll run that one. Cool. Again, this was extra, probably a good thing to have, but it doesn't, this was a rule that was supposed to happen. So it's good to test that it does what it's supposed to do here.
When you do do you want us to have separate functions for each of the different formats, or could you just do text change alignment and then run it once doing estimate and then kind of change the numbers a bit?
So you could. That gets a little messy when you're trying to do the arrange act assert format. So then testing it twice in the same function, it works. It's probably not convention though. So usually you want one method per thing that you're testing. But it's just a style. Yeah. So I could change alignment, get the alignment, change alignment again, and get a second alignment and assert first alignment matches this, second alignment matches this.
You can just so you have the text and then you just change alignment to alignment. You kind of
yeah.
So instead of doing it you just change it in the actual text, but you're not having separate. That makes sense.
So you would put both like this. You'd have in a single test function, you'd have this test and this test. Is that what you're saying?
No, well, you just have it once, right? And then you run it once to make sure that it works. Okay. And then you
so you would change your test. Okay, so you want to have both tests and you want to leave both tests. Yeah, because that way we will have them the next time we want to run the tests. Yeah, so I see what you're saying, that we could have changed it here to test it once, but once it's tested, you want to leave that test there because that way every time we run our tests, every test will run. You kind of get this library of tests to make sure that this is the rule for what should happen, and we're going to check it every time. Yep. Oh my goodness, it's almost time for the bake sale. This is taking longer than I thought. I'm sorry. We're almost done though, because the other ones are really fast. Do you want to go run off to the bake sale? I'm sorry. It's recorded though. If you want, you can. Okay. Okay. I'm sorry. So for attack, right? When we're testing this here, we know that it will really, if these are true, this will happen. So a single unit test would get us 100% code coverage. Do we also want to test that if you're not within range, nothing happens? We probably do. Again, that's an extra, it's a nice to have, but just saying if it does this case works here. We don't have a good feel for did we actually do it right unless we're testing all the other things. So in terms of code coverage, you only needed one technically to get 100% code coverage. That's fine, you'll get points here. But what we should do is make sure each of our cases works. So say, hey, I'm chaotic, I can attack something. Hey, they're not my team, I can attack something. Or if they are my team, I don't attack them. Or if they're not within range, I don't attack them. To make sure that it is doing all of the things it's supposed to do just because I have a single if block here. Right? We could have written this as 3 different if blocks. Hey, if you're chaotic, you assess damage. If you're not in the same alignment, you assess damage. If you're not within range, we could have written it different ways. So it just kind of comes down to how you write it here. But this will be self-attack, other team within range. Okay, so we need 2 ships. So we'll have an expected health, target health maybe, target current health is, I don't know, we'll say 5. Sure, so we'll make a ship. So this will be ship equals a ship. We don't care about the name. X and Y do matter. We need to be within range. Sure. Alignment.us. So the us team will attack a them team. This one's important. Then our current health, sure, is 10. Then is it range or attack power? Range first. So range will say, I don't know, 5 and attack power 5. And then we'll have a target equals a ship. Again, whatever you call it here doesn't really matter. So it needs to be within range. So if I just put it at 1, 1, should be fine. Square root of 2 is less than 5. We're okay. Now I want it to be the other team, right? So alignment them. And then if it starts with 10 health and I do 5 points of damage with its attack power, it should go down to 5. Its range and its attack power don't really matter here, but sure, we can put them in. Then ship.attack the target. This is our assert. Then we'll get the actual target current health. Target.get current health. And we can assert equal the expected current health and the actual current health. Right? So other team within range should take damage. Oh, cool, that one passes. Then I'm just going to copy paste. So let's say, how about chaotic? So if we are chaotic, then we should attack anybody. I'll just put in another chaotic here just to make sure, because I know one of the things we checked is that the alignments don't equal. So these do equal, but we should also be checking with our OR that if you're chaotic, we don't care here. And it should work. Right? We're just going through verifying what we expect to have happen does happen here. Right, so that one worked. And then how about we say chaotic out of range. Out of range. So your health should stay at 10 if you're not within range. So if we put you at 5, 5, and your range is only 5, should be within range, right? So your current health shouldn't change. And that one passes. So I'm feeling better now that all of my different cases here have been tested. Again, we already had code coverage with just one, but I want like each of these to be exercised so that I feel good about it here. Because, okay, technically this is 3 lines of code, I guess. So we would short circuit. And there's a whole bunch of funny stuff here, but the if block ran. But now we're checking all these things here. So I'm happy with ship. You okay with ship and ship tests? Cool. Then we'll go make another class. So the next one we make then, how about is it the cruiser or battleship? We'll do battleship. So we need to import some stuff. So from ship, import ship. From alignment, import alignment. And we'll have a class battleship. Self.init. Self, oh my goodness. Define init. So battleship needs a name, right? It needs an X, it needs a Y, because we need to know where these things go, right? Because I need to tell ship where the X and Y are, and I don't know where a battleship goes. I don't know its alignment either, so it needs an alignment. Alignment, there we go. Needs an alignment. Max health for battleship, we know what that is. Its max health is 100. I don't have to give that as an argument when I make a battleship. Its attack power and its range, I know what those are. They're fixed. We don't need to have those as arguments here. So that's all we really need for battleship. So then to do that, we'll call super init, given name, X, Y, alignment, health was 100, range was 10, attack power was 10, something like that. Yeah, range is 10, attack power is 10, max health is 100. So I just give those values to my superclass init method. Great. And then I have a self.torpedoes. Torpedoes is 10. Torpedoes? How do you spell torpedo? Rename to... All right, doesn't know how to spell it. That's fine. Sure. Right, that's what's different with Battleship. Then we're going to define a get type here. We're going to return Battleship because it needs to return the correct type. This is its class name here, right, for Battleship. Awesome. Then a move. It always moves -1, -1. So define move. So I want to do the superclass move to gain a health. Then I want to take my self.x location -1 and a self.y location location -1. Now, technically we're doing bad things here. We'll feel bad about it because we're accessing private values. It's not pretty here. It works, right? There's other ways to do it. It's okay. Other language. Oh, sorry. This should be ship. No wonder I was confused. Battleship inherits from ship. There we go. Now it knows what these things are. Okay, so move is different, and then attack is different, and status also needs to be different. So let's do status first. So status, we're going to return super status plus a formatted string of a new line, right? And then torpedoes, self.torpedoes. Right? We'll just add in whatever you did, my superclass did, add in my other line here. Great. Okay, and then attack, define attack, self-target. Now this one, we're going to do an extra damage, right? Extra 10 damage if we have a torpedo. So in ship here, well, the same rule applies and within range applies. So I kind of have the same stuff happening here. So I'm going to change this just a little bit here and add one more helper method. We'll say define should attack given a target. So should we attack them is this here, right? If my alignment is chaotic or my alignment is not their alignment, right? I should attack them. Okay, so then we can say self.should attack the target and targets within range. Look, now this all fits on one line, mostly on one line here. It's close. Okay, so now this is a little easier here for me. I don't feel quite so bad for copy pasting. So if we should attack the target and the target's within range, then, well, before we assess damage, we can check. So we'll have a damage then should equal my self-attack power. And then if self.torpedoes is greater than 0, damage plus 10, self-torpedoes -1, and then assess the damage here. Again, lots of different ways of doing this. Great, that's fine. Not too big of a deal here. However you wanted to go about that. Does this make sense for attack? Cool. Again, trying to have the least amount of copy-pasted code as possible. I still need to use these functions, but now at least they're functions I can call rather than having some rules here. And then later in the game, if we want to add like a third team, we have an us, we have a them, we have chaotic, we want to add a purple team or something. You know, what needs to change is just the should attack. You know, and we can add rules a little bit more easily if we have shared functions rather than copy-pasted code. You know, or like, hey, your team has made an alignment with this team, you no longer shoot at them. Hey, you've broken the alignment, now you do shoot at them. And all sorts of fun stuff can happen that later down the road we don't have to worry too much about. Okay, that's it for Battleship. Now we need to test it. So we're going to go to test, create a test. We test move, status, attack, get type, might as well. Okay, so from Battleship, import Battleship. Awesome. So testing Battleship. So we need a ship equals a Battleship. Now we don't care about the name here. We're just testing type here. We don't care about the X. We don't care about the Y. We don't care about the alignment. Us, sure. Oops. Alignment. Import alignment. There we go. Okay. Then we'll have we have an expected type. Battleship. And we have an actual type of ship.getType. And then we kind of self-assert equal my expected type, my actual type. Right? Great. Move then. We already tested that move increases our health, so I don't really care that it does. I mean, we probably should also check that it increases our health because we want to make sure our call to super works. So in terms of code coverage, it runs anyway, but we want to check to make sure it did what it's supposed to do. So we'll make a ship then, and then we're going to have an expected x is -1, expected y is -1, and an expected, oh my goodness, current health, we'll say like 91. So maybe we'll do 10 points of damage to it just to make sure that goes up. So then I'm going to assess some damage so that when I call move, I see that it increases. Then we'll call ship.move, and then we'll get the actual x is ship.getx. We'll have an actual y is ship.getY, and then we'll have an actual current health ship.getCurrent health. Okay, and then we can assert. So assert equal. We'll do 3 of these, x, y, and health. Expected x, expected y, expected current health, and the actual x, the actual y, and the actual current health. Right? So should move and should gain a health. Cool, that one passes. Feeling good so far. Status. I'm just going to go steal ship status here because this is pretty much the same. We're just going to add some torpedoes here, and I won't have to retype it all. Where's my status? This one here. So testing here, now this is a battleship, right? Battleship. Ship. Its health should be 100, but should stay at 1, 2, right? And we don't give it any of these other values. And then we should also have torpedoes, right? So then torpedoes is 10. I'm spelling it wrong, but that's fine. It's okay. Oh, so this one failed here. Oh, tabbed in, right? Because this is that string. It has to be lined up better. Try it again. All right, now that one passes. Cool, so status was good. Now attack, right? Because I'm using these functions here for within range and should I attack, I'm not going to bother doing those again because I know I tested them in ship. So I don't have to repeat 3 different tests for this one. What I do care about is if I'm doing torpedo damage or not, right? So let's go and make some ships. So we need a ship equal to battleship, right? Sure. Ship is a battleship, and then we'll have a target. I'm going to make this another ship here because I want to do some other stuff. So we'll say alignment them. Now, excuse me, they need a bunch of health here because I want to shoot 10 times to use up every single torpedo and make sure the 11th shot does the regular amount of damage. Does that make sense? So I'm going to say like 250 here. I guess we got to import ship. So from ship, import ship, 250. 0 and 0. That's fine. So then I'm going to have an expected health after first shot should be 20 points of damage, right? So it should be down to 230. 10 plus my 10 for torpedoes, and my expected health after 11 shots. So it should be 200 for the 10 plus 10 more. It should be 110. 210 left, so it should be down to 40. 11. I can't spell, friends. All right, so we'll shoot. Attack the target, and then we'll get the current health. So this is the actual current health. Current health after first shot. My target get current health. Okay. Then I want to attack 10 more times. So for attack in range 10, ship.attack target. Then we'll have an actual current health after 11 shots. Target get current health. And then we'll assert. So assert equal. The expected current health after the first shot is the actual current health after the first shot. And then we'll assert the expected current health after 11 shots is the actual current health after 11 shots. Right? If you wanted to do them separately, that's great too. But just we want to make sure we're using all the torpedoes and we no longer do torpedo damage when we're done. We also could check then that our torpedoes went down, right, to make sure that that's properly being counted. It's probably a good thing to check here. I guess we can have an expected torpedoes. Torpedoes is 0. We'll have an actual torpedoes. Torpedoes. Ship.get torpedoes. I guess we don't have a function for that, do we? That's all right. We'll go write one in a second. Insert my expected torpedoes and the actual torpedoes. We'll go add that here. So we'll define a get torpedoes, turn self torpedoes. All right, let's see if that one runs. And that one passes. Cool. So again, we had the code coverage, but making sure that all the things change that we expect to change is probably a good thing here. And if you wanted to check it at 9 and check it again at 0, that's probably overkill, right? We didn't know it's subtracting. Maybe we test. I mean, this is good because we've shot 11 times. We didn't get into negatives. So checking that it got to 0 and stopped at 0 is probably a good thing too, because we did 11 shots. So, I feel pretty good that Battleship does what it's supposed to do now. Okay. My goodness, we're almost out of time. I'm sorry. I think I'm talking too much. New. So we need a cruiser. So let me go copy my imports here. I guess we didn't even need the alignment, did we? That's fine. So this is our class cruiser. Inherits from ship. Now, cruiser is pretty easy here because it has own range, attack power, health here. Move is special. Attack doesn't do anything different. There's no different thing in attack. We don't need to change anything, but we also need to get type. Right? So we'll have a define init that takes a name, takes an X, takes a Y, takes an alignment. Right? Same like Battleship did. We call super init. We pass name, X, Y, alignment, and then we pass the health was 50, range was 50, and attack power is 5. Sure. We just pass all those done up. There's nothing else we need here. That's it. We define a move, right? Call super move again to gain our health, and then we'll take our self.x and y. I'll just go steal those out of here. That way I don't have to type as much. And what do we say? These ones move at 1, 2. So x goes +1, +2. Great, we moved. Define get type. Return cruiser. That's it. Attack works. It is already done. We don't need to change attack. We're not overriding any sort of behavior here. Okay, so then for testing, we just have type and move. That's it. Nothing else needs to be tested here, which is fun. We go to test, create some tests, move and type. From cruiser, import cruiser, and from alignment, import alignment. Awesome. So we need a ship equals a cruiser. We don't care what the name is. We do care where it moves to, right? Alignment us. So then we'll have an expected x. So it moves 1, 2, right? So it should go to 1, expected y should go to 2, right? We'll call ship and then we'll test, right? We call ship move. I guess we could do the health too, right? Expected current health. Maybe 41, so we'll make the ship and we'll do 10 damage. It's just nice to know that we properly did that call to the superclass, because that also should happen here. So we call move, and then we'll get the actual x, ship.get x, an actual y, ship.get y, and an actual current health, ship.get current health. And self is start equal. Right? The expected x, actual, and the actual x. Right? Copy paste a little bit here, change that to y, change this one to y, and health. Expected health, and the actual health. All right, awesome. So we'll test move. Cool, that one passes. And then test get type. Well, that one's pretty easy. That's just is going to be that we get back cruiser. So the expected type is cruiser. and then the actual type is ship.getType, right? And then we'll assert the expected and the actual. All right, cool, that one passes. Oh, 2 minutes left. I'm so sorry. Do you want to talk about the next project real quick? It's pretty fast, so let me go do that. Let me pull up a new link for us. I had it in my head this went faster. I'm sorry. I don't know why this is going so slow. And I started late, obviously. I'm sorry. That would have helped. Come on. All right, come back to Canvas. This is 2001 or 2023, project 0. I haven't been watching chat at all. I'm sorry. Someone is, yeah, torpedo. Okay, thank you for selling torpedoes. Yeah, so ideally, if you just committed your UML diagram to the repository, you can just give me the repository link. And that should be fine. Oh, hang on, that was weird. There it goes. It was not checked before, was it? All right, Chesky Python template. All right, so we're going to build a recursive solution to help us figure out our best move in checkers. We got 2 weeks for this one. So this is the 26th. We'll go to the 9th at 2 p.m. I think that picked it up right. 2 p.m. Okay, good. Please submit the URL to your repository. So let me go grab this here. It's a copy paste. You're probably not surprised. We did this one last time and it was fun. Project 2, project 1. There we go. Oh no, this is not it. Where's my checkers one? Oh, I did the wrong one here. I think I have it here. Nope. Winter. I don't have it in here. Yes, I have it in here somewhere. Checkers? No? Where's my checkers? All right, friends, I'm going crazy. I'm sorry. Where's checkers? It's been a good day. It's been a really good day. Let's find checkers. No. Oh my goodness. All right, I don't have it there. That's all right. So we're going to build a checkers solving program to help the user find the best possible move in checkers. We're going to create a 2D list for the board. We'll have B for black pieces, W for white pieces, just a space for empty spaces. So checkers, right, is a chessboard. Checkers board is an 8x8, alternating colors. So we need to be able to accept any given board here. Should make sure that it's valid, right? So so the init method should accept the board, sure it's a valid checkerboard, or raise an exception. So if I give you pieces, they all need to be on white squares or on black squares. I don't care one or the other. There might be one is better than the other. I don't actually play checkers, or I haven't for years. My grandfather liked checkers. Really good at it, weirdly. Probably because I was little. So accept a board. It will have some black pieces. It'll have some white pieces. It'll have spaces for empty. Right. So all the white will be empty, or all the black will be empty, or it's invalid. Right. You can't have pieces on white and black. Right. And then what it needs to do then, so for every white piece, calculate the maximum number of jumps it can go. So we're going to see, so if you have 3 white pieces on the board, how far can this white piece jump? And we're going to assume all pieces are kings. So kings can go forward and backwards in checkers. This will make life probably a little easier, because otherwise it becomes a king at the last row, and then you have to like calculate a bunch of other things. So just assume they're all kings to start. So it can go forwards or backwards for its jumps here. So the idea, this is a using backtracking recursion. So same like we do with the maze solver, we're just going to try something, see if we can go further, try something, see if we can go further, try something, see if we can go further. Like we did in lab, we need to undo those steps. The first example we did last week was it just solves it and quits. You don't want to solve and quit, because we need to test for every single white piece on the board how far it can jump to get the max number of jumps. So we need to be trying things and then undoing those as we come back. Right? So once I jump over a piece, it comes off the board. I can jump over the next piece, it comes off the board, jump over the next piece, it comes off the board. When I'm done with that path, right, I have to undo those steps, undo those jumps to come on back here. So backtracking recursion to solve for that here. This is just the URL here. Right, I'm sorry we ran over time. This has not been the day I wanted it to be. But this is what I'll be working on. So for any given board, it needs to work. Right? And we're going to check and make sure it's a valid board. So 8x8 board, probably a good thing to check too. It should work for bigger sizes, but that's something we can check and make sure the pieces are valid spots here. Because if you have pieces in weird places, weird things will happen. So, right, and that sort of idea, right? You can jump diagonal this way, you can jump diagonal that way, you can jump diagonal this way, you can jump diagonal this way. We're doing diagonals instead of our maze solver was up, down, left, right. We just now like rotated a little bit. So we're jumping diagonals, right? So can we do these things? We have to check and we have to try them and recurse to find the max possible jumps here. So similar idea where we found the shortest possible path. Now this is the max jumps, just flipped a little. Okay. All right. Thanks for putting up with me. I'm sorry. It's been a day. Appreciate you folks.